right, so you're a developer, and time is precious. Let's get right to it.
Today we're diving into on-device AI,
Ooh, very cool.
specifically Adobe's SlimLM,
Okay.
which lets you run powerful AI directly on a smartphone,
Wow.
even offline.
Interesting.
Imagine the possibilities for your apps.
Yeah, this is a game changer.
So we've got a research paper straight from the source,
Okay.
arxv.org,
Mm-hmm.
detailing SlimLM's inner workings,
Right.
and we'll be connecting it to a fascinating concept called knowledge distillation from an IBM article you shared.
Yeah, awesome.
Okay, so let's unpack this.
Okay.
Why is on-device AI such a big deal? I mean, we've got the cloud, right?
Sure, the cloud's powerful, but it comes with baggage costs, latency,
Right.
and those pesky privacy concerns.
Yeah.
Healthcare, finance, law.
Mm-hmm.
They all handle sensitive data that clients might not want floating around in the cloud.
So SlimLM sidesteps all that by running locally.
Exactly.
That's pretty slick.
And it's not some pie-in-the-sky concept either.
Adobe Acrobat is already using SlimLM on mobile for things like document summarization,
Oh,
question answering,
sure.
even suggesting relevant questions,
That's wild.
all without an internet connection.
But how they cram all that AI power into a smartphone?
That's where the Slim in SlimLM comes in.
Oh, okay.
The research paper dives into how they shrunk these models down to run efficiently on mobile hardware.
Okay.
Their smallest version has a mere 125 million parameters.
Wow.
For comparison, behemoths like GPT-4o have hundreds of billions.
Okay, that's tiny. But how does it still pack such a punch?
That's where knowledge distillation comes in.
Okay.
Think of it like this. A seasoned developer, the teacher model,
Okay.
is mentoring a junior developer,
Mm-hmm.
the student model, which is SlimLM.
Okay.
The student learns from the teacher's experience and expertise, but doesn't need to carry around all the baggage of that experience.
So SlimLM inherits the smarts of a larger model without needing its massive size.
Precisely.
That's brilliant.
And to tailor SlimLM for document tasks, they created a special dataset called DocAssist.
Okay.
It's got around 83,000 documents,
Wow.
specifically curated for training on things like summarization and question answering.
So they fine-tuned it to be a document processing ninja, basically.
Yes.
What I'm curious about is how did they actually build this student model? I mean, it can't be as simple as just shrinking a large model, right?
You're absolutely right.
Yeah.
There's a lot of clever engineering involved.
Yeah.
The research paper goes into the specifics of their approach.
Okay.
They chose an architecture called MPT as their foundation.
MPT.
Interestingly, they decided not to use a technique called alibi positioning, which is commonly used in MPT models.
Okay, so why ditch the alibi method? What's the logic there?
Well, alibi is great for handling variable length sequences.
Right.
But SlimLM is primarily dealing with fixed length inputs and outputs in document assistance tasks.
Oh.
So they didn't need that extra complexity.
It's all about optimizing the architecture for the specific job at hand.
Right.
Makes sense. It's like choosing the right tool for the job.
Exactly.
No point using a sledgehammer to crack a nut, right?
Right.
So they customized the MPT architecture for document tasks.
Yes.
Did they do anything else to enhance its ability to understand and process documents?
It did. They incorporated biases into the model's layers.
Yes.
Think of these biases as little nudges that help the model differentiate between tasks like summarization,
Yeah.
question answering, and question suggestion.
Mm-hmm.
It's like giving the model a cheat sheet for understanding document nuances.
So they're giving the model extra guidance to excel at document-specific tasks.
Yes.
I like it. They're really tailoring this for real-world use cases.
Exactly.
Speaking of which, they also developed a specific data set to train SlimLM, right? Something called DocAssist. That's the story there.
Yeah, DocAssist.
Yeah.
That's where their commitment to practical applications really shines.
Yeah.
They didn't just rely on existing data sets.
Mm-hmm.
They meticulously built their own, specifically designed for those real-world document tasks.
So they wanted to make sure SlimLM was trained on data that mirrored the kinds of documents it would encounter in the wild.
Exactly.
That's smart.
They gathered over 82,000 publicly available documents.
Wow.
Illustrations, presentations, spreadsheets,
Oh,
even machine-generated content
wow, that's quite a range.
for a really diverse collection.
And sounds like they aimed for a comprehensive snapshot of what people actually work with.
They did.
Mhm.
And they took the extra step of pre-processing all that data.
Okay.
Using tools like TickToken and even GPT 3.5 Turbo.
Wow.
They tokenized and segmented the documents into manageable chunks.
Okay.
Each document ended up with a maximum of 1,000 tokens after processing.
Okay, so they prepped the data to be easily digestible by the model.
Exactly.
That makes sense. But then they had to annotate it all, right?
Yes.
Labeling the data for those specific tasks.
Yes.
How did they handle that? It sounds like a massive undertaking.
It was. And this is where they got really innovative. They leveraged the power of GPT-4o Mini to generate high-quality annotations for all 3 tasks in Doc Assist.
Wait, they used AI to help annotate the data?
They did.
That's pretty meta.
It is.
So how did that work?
They created a specific prompt for GPT-4o Mini,
Okay.
instructing it to annotate each document for summarization, question suggestion, and question answering.
Okay.
They even included detailed requirements and examples in the prompt to ensure accuracy and consistency.
So they guided the annotation process carefully to maintain quality control.
Yes,
That's a clever use of existing AI tools to streamline a complex process.
it is.
But I'm curious, why go through all this trouble to create a custom data set?
Right.
Couldn't they have used existing data sets for training?
Well, while there are existing data sets for tasks like summarization and question answering,
Right.
they often lack the diversity and real-world relevance that Doc Assist offers.
Okay.
Remember, SlimLM is designed for practical on-device applications, so training it on a data set that closely mirrors those real-world scenarios is crucial.
That's a great point. It's all about ensuring that SlimLM is truly prepared for the challenges it will face in real-world deployments.
Exactly.
They didn't cut any corners,
Nope.
so they've got this meticulously crafted data set.
Yes.
What's next? How do they actually put it to use in training SlimLM?
Well, they split the Doc Assist dataset into training, validation, and test sets.
Okay.
This allows them to train the model on one portion of the data,
Right.
use another portion to fine-tune and adjust the model's parameters,
Okay.
and then finally use the remaining portion to evaluate how well the model performs on unseen data.
It's like giving the model a practice exam before the real deal.
Exactly.
Makes sense.
Yeah.
But we're still missing a key piece of the puzzle.
Okay.
How does knowledge distillation actually work in practice? What's the secret sauce that allows SlimLM to inherit the knowledge of a larger, more powerful model?
That's a great question. And to understand the answer, we need to delve a bit deeper into the technical nuances of knowledge distillation.
Okay.
Essentially, the teacher model,
Mm-hmm.
which is a much larger and more complex model,
Right.
is trained on a massive data set.
Okay.
This teacher model develops a rich understanding of the nuances of language and the specific task at hand.
Okay, so the teacher model becomes an expert.
Yes.
What happens next? How does the student model, SlimLM, learn from this expert?
Instead of just training SlimLM on the original training data,
Right.
they use the teacher model's output probabilities as soft targets.
Okay.
Think of it like this. The teacher model doesn't just give the student model the correct answer.
Mm-hmm.
It provides a probability distribution over all possible answers,
Okay.
indicating its confidence in each possible answer.
So the student model isn't just mimicking the teacher's answers. It's learning the teacher's thought process, its reasoning, and its level of confidence in different possibilities.
Exactly.
That's fascinating.
By learning from these soft targets, the student model gains a much richer understanding of the task than it would by simply trying to match the teacher's final answers.
Right.
It's like learning from a master chef.
Okay.
You don't just learn the recipe, you learn the techniques, the nuances, and the intuition behind the dish.
That's a fantastic analogy.
Thank you.
So the student model, SlimLM, is essentially learning to think like the teacher model, inheriting its knowledge and expertise.
Precisely.
But how does this translate to actual performance improvements? Does this approach really make a difference in how well SlimLM performs?
It absolutely does. The research paper highlights that SlimLM consistently outperformed or matched the performance of similar-sized counterparts across various metrics, even though it was significantly smaller.
That's impressive. So knowledge distillation isn't just a theoretical concept.
Yeah.
It's a practical technique that translates to tangible performance gains.
It is.
That's really exciting. But before we dive into the nitty-gritty of those performance results, let's take a step back and think about the bigger picture. What are the real-world implications of having AI this powerful running on our phones?
The implications are profound.
Yeah.
Think about the possibilities for personalized learning,
Mm-hmm.
on-the-go document processing,
Right.
offline language translation,
Yeah.
and even AI-powered healthcare diagnostics,
Wow.
all right in the palm of your hand.
It's mind-blowing.
It is.
And the fact that SlimLM is open source means that developers like you can start experimenting with this technology and building incredible applications.
Absolutely.
But let's not get ahead of ourselves.
Okay.
We've covered a lot of ground already, and I think it's time for a quick recap.
Sounds good to me.
Okay, so we started by understanding why on-device AI is such a big deal.
Right.
It offers advantages in terms of cost, privacy, and offline accessibility that cloud-based AI simply can't match.
Exactly.
Then we dove into the heart of SlimLM, understanding how they achieved such remarkable efficiency by shrinking down these models and leveraging the power of knowledge distillation to maintain performance despite their smaller size. And we can't forget about the DOCASys dataset, their meticulously crafted training ground for honing SlimLM skills in real-world document tasks.
Yes.
They truly went the extra mile to ensure that SlimLM is ready to tackle the challenges of practical on-device applications.
Absolutely. So far, we've laid the groundwork.
Right.
We've explored the motivations behind on-device AI, delved into the intricacies of SlimLM's design,
Right.
and uncovered the secrets of knowledge distillation.
Yes.
Now it's time to see how all this translates into real-world performance.
I'm ready to see SlimLM in action. Let's dive into those performance results and see how it stacks up against the competition.
Awesome, let's do it. All right, so we're ready to see how SlimLM performs. Let's jump right in. The researchers didn't just stop at building the model and dataset. They actually put SlimLM through its paces, testing it rigorously on a real smartphone, a Samsung Galaxy S24. They really wanted to understand the practical limitations of deploying these models on mobile hardware.
That's smart. Getting out of the theoretical and into the real world, what kind of tests did they run?
They tested a whole range of state-of-the-art models, from a small 125 million parameter model all the way up to a massive 8 billion parameter model. They use a framework called MLC-LLM for quantization and deployment. Because it's versatile, it supports a bunch of different models and lets you use the phone's GPU.
So they were pushing the limits of what's possible on a phone, not just running some simulations in a lab. Did they have to make any compromises to get these models to run on mobile?
Absolutely. One key technique they used was quantization. They quantized all the models down to 4-bit using the group quantization method. It's a clever way to shrink the models and make them less computationally intensive without sacrificing too much accuracy.
So it's like compressing a file to make it smaller.
Yeah.
But for AI models, did they just focus on model size, or were there other factors they had to consider?
Model size is important, but they also had to think about context length. Remember, these models are designed to work with documents, which can be pretty long, so they tested context lengths up to 1,000 tokens to see how well the models could handle longer inputs.
That makes sense. A model that chokes on a long document isn't going to be very useful in the real world. So what did they find? Was there a sweet spot in terms of model size and context length?
There were definitely some interesting trade-offs. They measured things like input and output tokens per second, time to first token, and overall runtime, to see how quickly the models could process text and generate outputs. As you might expect, smaller models like SlimLM and Qwen 2 were faster, but sometimes struggled with accuracy compared to the larger models.
So it's a balancing act between speed and accuracy. You want a model that's quick and efficient, but also reliable. Did longer input lengths affect performance?
Absolutely. As the input length grew, inference speeds slowed down across the board, highlighting the challenge of processing longer pieces of text. When the input context approached 1,000 tokens, smaller models really struggled to keep up, while larger models ran into memory limitations.
So finding the right balance between model size, context length, and available resources is crucial for mobile deployment. Did they have any recommendations based on their findings?
They did. They found that mid-sized models, like Qwen 2.5b Instruct, often struck a good balance. These models offer decent speed accuracy and the ability to handle reasonably long input contexts without completely bogging down the phone.
That's helpful. So it's not always about going for the biggest, most complex model. Sometimes the most practical solution lies somewhere in the middle. Speaking of practical solutions, let's get back to the DOCASys dataset. You mentioned earlier that they created it specifically for training SlimLM on those real-world document tasks. Can you walk me through how they designed and built this dataset?
Of course. They wanted to create a dataset that was truly representative of the documents people encounter in their daily work. So they gathered a diverse collection of over 82,000 publicly available documents. We're talking illustrations, presentations, spreadsheets, even machine-generated documents.
Wow, that's a pretty comprehensive collection. Did they just throw all these raw documents into the dataset, or did they do any pre-processing?
Oh, they definitely didn't just dump them in there. They used a combination of tools, including TikToken and GPT 3.5 Turbo, to tokenize the documents and segment them into chunks, ensuring that each document contained a maximum of 1,000 tokens after pre-processing. This helped ensure consistency and made the data easier for the model to digest.
Makes sense. You would want to overwhelm the model with giant blocks of text. But preparing the documents is only half the battle, right?
Yeah.
They still needed to annotate the data for the specific tasks they wanted SlimLM to perform.
Exactly. And this is where they took a really innovative approach. They actually leveraged another AI model, GPT-4 Mini, to help them generate high-quality annotations for summarization, question suggestion, and question answering.
That's amazing. So they used AI to help them build the data set for training another AI.
Yeah.
It's pretty meta. How did that work exactly?
They crafted a very specific prompt for GPT-4 Mini, instructing it to perform these tasks sequentially for each document. This prompt included detailed requirements, in-context examples, and even task-specific instructions to ensure that the annotations were accurate, relevant, and consistent.
So they weren't just letting GPT-4 Mini run wild. They were carefully guiding the annotation process to ensure high-quality results.
Did they run into any challenges or interesting findings during this process?
They did. One challenge was ensuring consistency and quality control across such a large data set. To monitor this, they tracked the token usage by GPT-4 Mini during annotation. They found a relatively low standard deviation in completion tokens, suggesting that the model was generating consistent length responses across different documents, which is a good sign for quality control.
That's reassuring. It sounds like they really put a lot of thought and effort into crafting this DocAssist dataset. It's not just some random collection of documents. It's a meticulously curated and annotated resource specifically designed to train SlimLM for real-world success.
Exactly. They didn't cut corners, and this meticulous approach paid off in the end. They were able to train SlimLM to achieve those remarkable results we talked about earlier. So the DocAssist dataset was instrumental in fine-tuning SlimLM to excel in those document tasks. It's a testament to the power of having high-quality task-specific data for training AI models. But before we dive into the performance results, I want to touch on something you mentioned earlier, open sourcing SlimLM. Can you elaborate on that? Why is that such a big deal?
Open sourcing SlimLM is huge because it allows developers like you to access the model, experiment with it, and potentially build your own applications on top of it. It's a way of democratizing access to powerful AI technology and fostering innovation within the developer community.
That's fantastic. It really opens up a world of possibilities. Now I think we're finally ready to see how all this hard work and innovation translates into real-world performance. Let's delve into those results and see how SlimLM stacks up against the competition.
All right, let's get to the exciting part, seeing how SlimLM actually performs on those document tasks. Remember, before they fine-tuned these models on the DocAssist dataset, they couldn't really do much with documents. They had a general understanding of language, but no specialized knowledge of summarization question answering or question suggestion.
So it was the DocAssist fine-tuning that really unlocked SlimLM's potential.
Exactly. After fine-tuning, most of the models achieved near-perfect accuracy on intent detection. This means they could reliably figure out what the user wanted to do with a document, whether they were asking for a summary, looking for answers, or trying to generate questions.
So they aced the first test, understanding the user's intent. But how did they fare on the actual document tasks?
The research paper has a whole section comparing SlimLM against those baseline models across all three DocAssist tasks, and the results are pretty impressive.
I'm all ears. Give me the highlights.
While SlimLM consistently outperformed or at least matched the performance of similar-sized models across a range of metrics. For example, SlimLM 125M, the smallest model, actually beat out SmallM 135M Instruct on tasks like summarization and question answering.
Wow, so even the little guy was holding his own against the competition. That's a testament to the efficiency of their design and training approach.
Absolutely. And as they scaled up the model size, the performance just kept getting better. SlimLM 450M and SlimLM 760M achieved comparable results to Qwen 2.5b Instruct, even though Qwen 2 was trained on a much larger dataset.
That's remarkable. They were able to get similar performance with a smaller model and less data. That's the power of knowledge distillation and task-specific training in action.
Precisely. And their largest model, SlimLM 1b, even came close to matching the performance of the much larger Qwen 2 1.5b Instruct. This shows that SlimLM has the potential to deliver competitive results with significantly less computational overhead.
It makes you wonder what they could achieve with even larger SlimLM models down the road.
It's exciting to think about. And remember, they achieved all of this while efficiently handling those longer document inputs, which is crucial for real-world applications.
So SlimLM isn't just a theoretical concept. It's a practical solution that's ready to be deployed on mobile devices. That's what really sets this research apart.
I completely agree. They didn't just stop at developing and evaluating the model. They went a step further and created an Android application to showcase SlimLM's capabilities in a real-world setting. Imagine having this kind of AI power right in your pocket.
It's truly groundbreaking.
Hmm.
This research is bridging the gap between cutting-edge AI and practical applications, making these powerful technologies accessible to a wider audience.
And the fact that SlimLM is open source amplifies its potential impact even further. Developers around the world can now tap into this technology, experiment with it, and build innovative applications we haven't even imagined yet.
It's a game changer for sure. As we wrap up this deep dive, what key takeaways would you like to leave our listeners with?
Well, I think the most important takeaway is that powerful AI is no longer confined to the cloud. SlimLM demonstrates that we can bring these capabilities directly to our devices, opening up a world of possibilities for personalized, private, and accessible AI experiences.
And I'd add that SlimLM is a shining example of how innovation and collaboration can push the boundaries of what's possible. By combining clever design, meticulous data preparation, and the strategic use of existing AI tools, the researchers behind SlimLM have created something truly remarkable.
Well said. And as we move further into the age of AI, it's crucial to remember that these technologies are tools that we can use to enhance our lives, our work, and our understanding of the world around us.
It's an exciting time to be a developer. With tools like SlimLM at our disposal, who knows what we'll be able to create?
The possibilities are truly endless.
And on that note, let's bring this deep dive to a close. We hope you've enjoyed this journey into the world of on-device AI knowledge distillation and the incredible potential of SlimLM. Until next time, keep exploring, keep innovating, and keep pushing the boundaries of what's possible with technology.